part of the video, on frame analysis and design. In this part, you will learn to assign the defined properties and loads to the frame members. You can now assign the defined frame section, ISMB 100, to the frame members. If you select from left to right, only the objects inside the selection area gets selected. Press Escape on your keyboard to deselect. If you select from right to left, the objects inside, as well as the objects touching the boundary of the selection area, get selected. After selecting the frames, go to the Assign menu, select Frames, and select Frame Sections. Select the smaller section, that is ISMB 100, and click on Apply. The sections of all frame members has changed to ISMB 100, with steel grade FE 345. Now, to apply the loads, select the first horizontal member, which has a uniform load of 8 kN. Go to Assign, Frame Loads, and select Distributed. Select Reset Form once, and enter the uniform load value of 8 kN per meter. Click on Apply, and then, click on OK. Select the next member, as shown. This member has a uniformly varying load, starting from 0, in the left end, and ending at 6, in the right end. Go to Assign, Frame Loads, and select Distributed. You can see that the previous value of 8 in the Uniform Load option is still there. Click on Reset Form to reset all values to 0. Now select the Absolute Distance option under Trapezoidal Loads. At 0 meter length, the load is 0, and at 5 meter length, the load is 6 kN per meter. So enter the values accordingly, as shown. Click on Apply, and then click on OK. Now, select the member in the first story, as shown. This member has a uniform load, of value of 4 kN. Go to Assign, Frame Loads, and select Distributed. Enter the value in the Uniform Load option, but before that, do not forget to reset the values. Give the value of 4, and click on Apply. The 4 kN per meter load has been applied. Select the rightmost horizontal member, in the second story. This has a point load of 3 kN, and 4 kN, at distances of 1 meter, and 3 meter, from the left end respectively. Go to Assign, Frame Loads, and click on Point. Select the Absolute Distance from End 1 option. At a distance of 1 meter from End 1 or the left end, the load is 3 kN. And at a distance of 3 meter, the load is 4 kN. So enter the values accordingly, as shown. Click on Apply, and then click on OK. The point loads have been applied on the selected member. Now select the leftmost horizontal member, in the first story, as shown. Go to Assign, Frame Loads, and click on Point. Click on Reset Form, then select the Absolute Distance option. At an absolute distance of 2 meter, enter the load value of 4 kN. Click on Apply, then click on OK. The uniform and uniformly varying loads are not visible, because the selected tab is only showing the codes. In order to view all loads together, just go to the Display menu. Select Show Object Load Assigns, and select Frame. Click on OK in the Options box. You can now see all the applied loads on the selected tab. There is still one load left to be applied, that is the horizontal load of 4 kN, acting on the vertical member. Select the vertical member. Then go to Assign. Select Frame Loads. And click on Point. First make sure to reset values, before making any changes. Now, In the Load Direction option, change the direction from gravity to X, as the load is acting in the X direction. Select the Absolute Distance option. At a distance of 2 meters, measured from the bottom of the member, the load is 4 kN, and is in the direction opposite to the positive direction of X. So, enter absolute distance 2, and load value -4. Click on Apply. The required load has been applied, as seen. Now, to view all loads together, repeat the step demonstrated previously. Go to the Display option, select Frame from Object Load Assigns, and click on OK. All the required loads have been now applied on the frame. In the next part of the video, you'll learn to analyze and design this frame. Thanks for